and the negative rules. Excuse me. Thank you. Okay. Do you remember from yesterday that product is fancy for what? Yeah, it's multiplying. Okay, what about quotient? Yeah, dividing. Good. Division. So, keep that in mind. We're going to need it in a second. We are going to do a little bit of calculator exploring. We're going to put a couple of these in the calculator and see if we can find any patterns. So I want everybody to do 5 to the 0 power. Yes, ma'am. Okay, well, let's hold that thought. So 5, and then the exponent button, the power caret, is between the clear and the division symbol. Okay, so 5 power caret 0. And then hit enter. Hold on. You want to tell everybody? It's 1. Good. All right. Go ahead and write that down. I'll write it down in a second. It's hard for me to flip back and forth. Now it's telling me that I want -7 in the parentheses, the whole quantity, raised to the 0 power. So I'm going to do open parentheses. You see the little baby negative with the little parentheses around him? That's the negative sign. The other one is like subtracting. So if I'm not actually subtracting anything, I don't want to do the big mamma jamma negative sign. I want to use the little baby one. So -7, close parentheses, power caret 0. Okay, any predictions for pi? Yeah. Yeah, probably. Let's test it. Okay, so pi is blue. How do you think we get all the blue stuff? We have to hit the blue second button. So that'll get you pi. Then do the power caret. And then we want a 0. Ta-da! You guys were right. It's 1. So 5 to the 0 is 1. -7 to the 0, also 1. Pi to the 0, 1. What do you think is going to happen to anything we pick and raise to the 0 power? Yeah. They all equal 1. So let's talk about y. Yesterday we learned about the quotient rule. Okay, and we just reviewed it before we started up the video. So the quotient rule says that if I have same bases and I'm dividing, I can just subtract my exponents instead of having to like cancel everything. Okay, so what hidden exponents are on these 4s right here? 1s. So this is 4 to the first and 4 to the first. So that would be 4 to the 1 minus 1 power, which is 4 to the 0. What do we know that 4 over 4 is? 1. Okay, let's look at this one. So if I have w to the third and I subtract the other power of 3, I get w to the 0. But I know from yesterday that if I have w's on top and the same number of w's on the bottom and I cancel, I'm just getting 1. It's because they're all canceling, right? They're all canceling and turning into a big old 1. Okay, so our negative power rule, just kidding, 0 power rule, negative is next. 0 power rule is that any quantity we raise to the 0 power is just going to be 1. Or you can write the number. That was my favorite when I was a kid because I just loved it when the teacher would give you something nasty and like your heart would sink and you thought you were going to die. And then you saw it was all to the 0 power and we were like, yes, I don't have to simplify it. I can just write 1. It was the best feeling because you thought you were going to die. And then it was like, oh, you were saved by the 0 power. It's the best. Okay, nobody else cares. That's fine. Fine, maybe my teachers were just really mean because they would put some really scary stuff in those parentheses. Let me tell you what. So look at this. All this stuff. Do we have to simplify it? No, because it's all going to the 0 power and it all turns into a 1. Okay, now you have to be careful, right? Look at these parentheses. All of this is being raised to the 0 power. Everything in the parentheses. But what about the -2? Not in the parentheses. So we have to bring the -2 down. Everything in parentheses that was to the 0 power turns into a 1. And then what's -2 times 1? -2. So almost as nice, but still, it could have been worse. All right. Really big number raised to the 0 power? Still 1. Doesn't matter. Now, we saw yesterday if we had the same power on the top and the same power on the bottom, and we had like 3 times 3 times 3 and b, like all of this was canceling, right? We saw that yesterday. So what we get to see today is that it's like 3 to the 2 minus 2, b to the 5 minus 5, c to the 7 minus 7. Each one of these is turning into a 3 to the 0, b to the 0, c to the 0, right? Because they're canceling. And they all turn into 1. What's 1 times 1 times 1? 1. Okay. Just a couple of different ways to look at the same thing. It makes me feel better in math when I can get the same answer thinking about it in more than one way. All right, now we're going to go do a little pivot. We're going to talk about reciprocals. Does anybody remember what reciprocals are? They have to do with fractions. Yes?
Reciprocals or reciprocals?
They're reciprocals. Okay. So you know that you have reciprocals if when you multiply them together and get a product, you get 1. Okay, so what is the reciprocal of 2/3? 3/2, 3/2. Do you guys remember this? It's upside down. So if I multiply across my numerators, I get 6. Multiply across the denominators, I also get 6, and I get a 1, right? That means I had reciprocals. Okay, so we need to know that because the word reciprocal is in the negative power rule. Okay, so keep that in your mind. Let's talk about negative power. We're going to need our friend the quotient rule again. So let's use our expanded form that we talked about yesterday. So we're going to make a great big fraction bar, put 2 w's multiplied together on the top and 5 on the bottom. At least it's not 15 this time. So what cancels? Yeah, these w's and these w's. What is left up here in the numerator? It's Not a 0. It's a 1. Yeah. Okay, it's just a 1 left behind, right? Because don't these cancel and make a 1? Right? Okay. So now we're going to use the quotient rule. So we're going to take our w squared and minus the 5. And what do you get? What kind of 3? A negative 3. So I did the expanded form and my w's are on the bottom. Okay, I did the quotient rule and I got this weird negative power. Don't those two things have to be the same, right? We simplified it. We should be getting the same thing, just two different ways. So what we get is that w to the negative 3 is equal to 1 over w cubed. Isn't that what I got here in my expanded form? So what is hiding in the denominator under the w to the negative 3? A 1. Do you see how these are reciprocals? What's the one difference? Okay. Yeah, and the negative power. So they are reciprocals. But their powers have different signs. Powers are, how do you feel about the word opposite? Okay, good. Guys, basically that right there in a nutshell is our negative power rule. So here it is, negative power rule. If I raise a term to a negative power, I'm going to get the reciprocal with what kind of exponent? Positive. Now, that is a lot of verbiage. Okay, it's kind of a lot to get used to. In practice, it's a lot easier than that. So we're going to do a few examples and then we'll look for some more patterns and examples on the back, okay? So look at this one. If I'm going to use the negative power rule on this one, I need to know what the denominator is under the x. A 1. Okay, so I need the reciprocal. So I put the 1 on the numerator and the x in the denominator with what kind of exponent? Positive 1. Do I have to write that positive 1? What's x to the first? X. So if I simplified it, it would just be 1 over x. That's not bad. All right, what about the next one? What is the reciprocal of 1 over 3? 3 over 1. But I have to change my power that was negative into a positive 2. What is 3 over 1? 3. And what is 3 squared? Don't say 6. 9. Didn't that look like it was going to be a lot worse? Oui. Okay, what is the denominator of 2 that we can't see? A 1. So what is the reciprocal of 2? 1 over 2. Okay, now we have to change the negative 3 power into a positive 3 power. That means if I have it cubed, I have to write it 3 times. Multiply it with itself 3 times. So I'm doing 1/2 times 1 half times 1/2. So if you multiply across your numerators, 1 times 1 times 1 is just 1. What's 2 times 2? 4 times 2, 8. So it's just 1/8. Okay, that's that one. Now, it's pattern time to make your life easier. If I had a negative exponent in the numerator, it went to the denominator with a positive exponent. If I had a negative exponent and something in the denominator, it went to the numerator with a positive exponent. You see this? It just changed sides of the fraction bar. Okay, this one started on top with a negative exponent, and it went to the bottom. So, this x squared, does it have a negative exponent? No. So we're going to lock this in place. It's not going to move. Lock. Does not move. Okay? X squared is just going to stay where it is. But is that z to the -3 happy down there where I have it in the denominator? Where in its heart and soul does it really want to be where it can have a positive exponent? Up top in the numerator. So let's give it what it wants. Okay, so my x squared is locked. It stays on the top. My z to the 3rd power goes up and joins it. If there's nothing left down there, do I still have to write the 1? No. Good. All right, let's look at E. Let's use the quotient rule on this one. The quotient rule says that when I'm dividing same bases, I get to subtract my powers. So I'm going to take the 2 and subtract the 3, right? So that gives me a to the -1. Now I'm going to do the same thing for the b's. I've got a 5 minus a 4. That gives me b to the +1. Now I do the same thing for the c's. What's 2 minus 7? -5. Good. Now, which one of those is locked in place because it already has, yes, the b. It already has a positive exponent. The b is locked. Lock. Okay. Who are the negative Nancy's that are not happy up there in the top? Yes, the A's and the C's. They're going to go down to the denominator where they will have positive exponents and quit whining. Okay, so the B to the 1st is locked, and then the A goes down, and the C's go down. And they have positive exponents. Okay. They're like spoiled toddlers. You just have to give them what they want, and then they are happy. That's true. Actually, they turn into better adjusted human beings if they don't get what they want when they're throwing a fit, right? But okay, give the variables with the negative exponents what they want. Okay, they're not actually toddlers. All right. It's time for some more patterns. We're going to start in the middle because the middle is easy. We already talked about the 0 power property. What is 2 to the 0 power? 1. Okay, for this pattern, let's write it as 1/1. What is 2 to the 1st power? 2. Let's write that as 2/1. What about 2 squared? 4/1. What about 2 cubed? Yeah. Do you guys see we're multiplying by 2 every time? Okay. What about 2 to the 4th? 16/1, and then 32/1, and last Good. Okay, that's the fun side of the table. I don't know, they're both kind of fun. It's hard to pick a favorite. All right, ask your calculator what 2 to the negative 1 power is. All right, so if I do 2 power caret negative 1, I do in fact get 0.5. Math, enter, enter. 1/2. Okay. 1/2. All right, let's do 2 to the negative 2. 2 power caret negative 2. Okay, math, enter, enter. Interesting. Yes?
It's like just swapping like the
You mean it's the reciprocal with a positive exponent? Oh,
Oh my goodness, guys.
oh my goodness. It's the negative power rule. It's so nice. Okay, so now that you figured out the pattern, you don't have to use your calculator anymore if you don't want to.
I do.
Okay. I'm going to allow it. Isn't that kind of fun to see? You guys are like, yeah, if you're into that, which I clearly am. Okay. So, on a related note, we have to pick all of these that are equivalent to 4 to the negative 2. So we just had 2 to the negative 2, right? We kind of know how to do that. Well, we can write a 1 under the 4. Okay, what is the reciprocal of 4 over 1? 1 over 4. And then I raise it to the positive exponent of 2. So do you see a match? Yeah, right here in the front. Okay, so if it is 1 over 4 with a positive exponent of 2, can it also have an exponent of negative 2? No, it has to be one or the other. It can't be both. You would be amazed at how many kids get this and then also pick this one. And I'm like, how? Like they did it right and then they pick this one. Don't do that. Okay? Okay, can we figure out what 4 squared is? What is it? Yeah, the 1 stays a 1 and the 4 squared is 16. So I say it's also this one. Now, if it is positive 1 over 16, can it also be negative 1 over 16? No, it cannot. So don't be the kid that picks both of those either. It can't be negative if it's positive. All right, can it be negative 8? No. All right, now we just have to check this one. What rule do we have to use to simplify that? We're multiplying same bases. Okay, we're going to add the exponents because it's the product rule, right? We're multiplying same bases. So what is 8 plus a negative 10? Negative 2. So 4 to the negative 2, is that a match? You betcha. That's what we started with, right? So that kind of looked like a lot, but was it too bad? It was kind of fun. Once you get on a roll. All right, here's another one. This one kind of looks like it has 2 powers. How can we simplify this so that we just have 1 power? What rule from yesterday do we have to use?
Power to power.
Power to a power, which says that what do we do with the powers? Yeah, we times them, we multiply them. So what is 3 times a negative 2? Yeah, so it's 3 to the negative 6. Well, shoot, I see that one right here. All right, now let's use the negative rule and simplify it. If I haven't told you yet, I'm going to tell you now. you're not allowed to leave a negative exponent in your answer. You need to simplify it and change it to a positive exponent using the negative power rule. Okay, so we have to find the reciprocal of 3, which is 1 over 3, and turn it into a positive exponent of 6. I see that one too. It's the first one. Okay. Wouldn't it be really nice if we knew what 3 to the 6th is? Okay, ask your calculator. What's 3 to the 6th power? Yeah.
3 to the 6 power?
Yeah.
3 to the 6 power.
Yes. But what is it just as an integer? Yeah. 729. So, I see another match. You guys see it on the far end? Okay, so if it's 1 over 729, can it be negative 1 over 729? No, so we're not going to pick that one. Can it be this one? No. All right, now we just have to simplify. So I'm multiplying across my numerators, so I get a 1, and across my denominators. So if I'm multiplying with same bases, what do I get to do to my powers? Add them. So 2 and 4 make 6. Looks like a match to me, because it's the same as that one over there. Questions? Yeah.
Is this a question?
So glad you're back. All right. So Meg simplified a problem. We don't know what problem it was, but we don't really care. We just need her answer. We want to know if her answer can be simplified any further. Are we allowed to leave a negative exponent in here? No. So the answer is that yes, we do have to simplify it. And using what rule? Yeah, the negative rule. Yes, using the negative power rule. Okay, so let's do that. First, we need to figure out what is the exponent on the 10. It is a 1. Okay, that 10 has a happy positive exponent. It doesn't want to flip. It wants to stay right where it is. It's fulfilling its life purpose in the numerator, okay, as the math gods intended. Okay, so this 10 is locked. Okay, it's not going anywhere. But the y, on the other hand, has a negative power. And it's going to be the reciprocal hanging out in the denominator with a positive exponent. So we'll have a 10 on top and a y to the positive 5th on the bottom in the denominator. They just want to fulfill their life's purpose. Okay? They just want that satisfaction in this world. Yep.
The real question is, why is life?
Okay. All right, so I want you guys to see if you can match up the ones at the bottom. Match them up. We're going to use them more than once. Okay, so if you're paying attention to those key words, that is the easiest problem in the world. So you're actually going to have a problem like that on SchoolNet, and it has like 9 or 10 things that you have to match. Okay? If you start getting them matched, like flip-flopped, you're not just missing one, you're missing the 2 that you got confused. Do you understand how it's like you'll lose double the points. So is that problem easy? Yes. Is it hard? Is it like also easy to hemorrhage points on that one if you're not careful? Yes. It can be a meat grinder if you start matching them up incorrectly, because then it's like errors on errors. So just be careful. You can go. That's it. Yep. Yep.
For tomorrow, whenever I take it, so I just want to figure it out.
No, I will put you on the AAR and you will go. I'm going to have you go to Mrs. Madsen's room. She's in 209. I will write that down for you. With my organized supplies.
After all that work.
I was gonna say, she just organized that. Your hard work was for nothing.
No, it's still organized. I knew right where to find them. Okay. Just a second.
What is this?
Mrs. Pass.
Yeah. See, I'm organized.
With one thing. It's underneath the desk to where you can't even see it. Are you organizing these orders? What is this? You are unbelievable. Okay, that's
This is the phone banana. So
Okay. Do you have questions about the map? Okay, it's work. Okay.
You are a crazy lady.
Okay, so what operations happen between the 8 and 5?
We got out of that really good hour.
Okay, how do we do that?
Oh, that's okay, Wednesday.
Yeah. You divide by the 8 and the 5 at the same time. This is all you want. Not a big one over. Because negative 25 is in this one good. Where, I think it's a line.
What? We won't go have to.
You don't have to go to the.
Oh,
yeah,
some
you
new
do.
ones.
You
I'm happy to do this.
put two on the top, and then make it high on the bottom. And that
Oh, wait, no, wait, do we leave that number, like, in there? And that one.
What about, Lloyd?
you see Chris's haircut?
It
Does
did.
it say a little TJ?
We're talking about the number things. And then, like, I don't know that.
Those are all the things.
Deep inside of me.
Okay. We did that last year for the Olympics. I love that song. I'm sad that I missed it.
Got a feeling
Wait, you might actually do one.
high on believing that you're in love with me. Got a feeling
Yes, yes,
high on
I'm not gonna
believing
sing.
that you're in love with me.
Okay.
I really like Minty. I really like the man. One.
No. You have a hostage.
Okay.
I don't want your reviews.
I don't either.
Bananas are nasty.
They are.
Seriously, they're absolutely disgusting. Anything banana flavored is nasty.
Okay, I'm
For real.
Especially lactose.
Oh my
Worst
god, it
thing ever
doesn't even taste like
invented.
banana.
Like, why would you create a banana flavored Laffy Taffy?
It doesn't even taste like banana.
Yeah, it just tastes like something gross that you pulled out of the toilet.
Sorry, Jordan. I'm happy that you like them. It's just not my thing.
Almost one. Good luck next year.
I have to eat a lot of food.
Either Auschwitz too.
Very streaming these days. Does it go after one geometry algebra?
Honestly, I don't know. Surprisingly, I failed algebra because I got quarantined 4 times. And I have a class.
Wow.
You did not get off the good part.
No, that was
Well, you
when
had a great
we
start. It just like the wheels came on. Didn't you get like a
You
100
heard.
on your first test?
were not on good terms that year. We were fighting like crazy, but then I got older and matured.
Of course.
I'm still not sorry about it.
That'll come later.
I matured. So I wouldn't listen to anything that she had to say to me. So I just kind of failed the class.
Oh.
Break the whole thing. There's a line. Yeah, you can go after. Huh? That's what I'm saying. If I borrow $1 and then I borrow $3 more, how much money do I owe you? They would be multiplied. You're adding negative, it's turning into a bigger negative. Well, you're up. Okay, now you know that you have to keep the same to the side. Yeah, so the two sides are always the same, so it doesn't matter what side. Oh, that was horrible noise. Horrible noises.
Sometimes when I think about annoying noises, it makes my head move.
Oh, I thought you were going to say, I think about you. And I was like, that's not very nice.